Misalignment between a three-phase motor and a pump occurs when the motor's shaft and the pump's shaft are not properly aligned. Misalignment can cause a variety of issues, including vibration, noise, excessive wear, and potential failure of components. It typically occurs in three forms. 1. Angular misalignment. The motor and pump shafts are at an angle to each other. This occurs when the center lines of the two shafts intersect but are not parallel. Effects: uneven load distribution, vibration, and wear on bearings and couplings. 2. Parallel offset misalignment. The shafts are parallel but not aligned on the same center line. This results in one shaft being horizontally or vertically displaced from the other. Effects: increased load on couplings, shaft bending, and accelerated wear. 3. Combined misalignment. A combination of angular and parallel misalignment. This is the most common type of misalignment in real-world systems. Causes of misalignment: improper installation, poor alignment during installation of the motor and pump, thermal expansion, temperature changes causing components to expand or contract, shifting alignment, foundation issues, settling of the base or uneven mounting surfaces, wear and tear. Over time, loosened bolts or worn couplings can lead to misalignment. Consequences of misalignment: increased vibration, leading to noise and reduced efficiency, bearing and seal damage, resulting in shorter equipment life, coupling wear. Misalignment can cause couplings to fail prematurely. Energy loss. Misaligned systems consume more energy due to increased friction and resistance. Alignment methods: straightedge and feeler gauges. Basic, cost-effective method, though less accurate. Dial indicators provide precise measurements of misalignment. Laser alignment tools, the most accurate and efficient method, used for critical applications, prevention and maintenance. Regular alignment checks during maintenance. Use flexible couplings that can tolerate minor misalignments. Ensure a solid and level foundation during installation. Monitor vibration and temperature for early signs of misalignment. Proper alignment not only extends the life of the motor and pump but also improves efficiency and reduces operational costs.